Hi, I'm Jamie.
And I'm Nathan, and we're excited to help you understand more about today's topic, motor oil. We're here at the Valvoline Lab, where scientists formulate the latest in lubrication technology.
In a survey of ASE-certified master technicians, over 85% agree that regular maintenance and a quality motor oil is one of the most important things people can do to take good care of their vehicles and keep them running well. So during this video, we'll talk about the lifeblood of your engine, motor oil. We'll also discuss high performance and protection and how to get the most out of your car or truck. You'll learn more about different motor oils and how to choose the right one for your car. Along the way, we'll destroy some common motor oil myths. The raw topics that this training covers include the primary functions of motor oil, what motor oil is, what causes oil contamination, how additives help oil do its job, oil specifications and their impact on formulations, oil types, how to choose oil based on engine needs, and finally, how often to change your oil. Now let's get started.
Great, let's do it. I'm a hands-on kind of guy. I like cars and trucks, and I like to keep mine running their best. Now, if you're like me, you're more into horsepower than chemistry. But it's important to understand the basic science of what's going on inside your engine. To help you understand how oil impacts the performance of your car or truck, let's start by understanding what motor oil does in your engine.
Now, you probably already know that engines have rapidly moving parts. They rely on combustion, the controlled explosion, or rather combustion of gas and air, to generate power. Engine components work together to transfer that power to the drivetrain so that the vehicle can move.
Whether you're going full throttle or just cruising, the primary function of motor oil is to lubricate and protect engines by keeping moving metal parts from touching. In ideal conditions, every bearing, shaft, pin, ring, gear, and cam inside your engine is separated by a film of oil when the engine is running. When those moving surfaces touch, they create friction and wear. Friction robs your engine of horsepower and efficiency, and you don't want that.
Wear is the grinding away of engine metals, and over time, wear can prevent the engine from running properly, or even cause the engine to fail. So a basic function of motor oil is to prevent friction and wear.
All right, check it out. We've got two metals. Rub them together and you can feel the resistance and hear the grinding. Now, add a little bit of motor oil and you can see and hear how the friction and wear are reduced. The oil film helps the engine achieve efficient performance and protects the engine parts over time.
Now, we said that we'd be giving you the inside track on some common motor oil myths. And here's the first one. It's a common misconception that the radiator and the coolant are the only sources of cooling in the engine, when in fact motor oil plays a vital role in keeping engines cool and running at proper temperatures, reducing engine heat by as much as 20%. The oil comes in contact with the bottom of the piston and the cylinder walls, some of the hottest parts of the engine.
So far, it's been simple enough. Your motor oil reduces friction and wear and helps to pull heat away from the core of the engine, working with the radiator and the coolant to keep the engine from overheating or even seizing up.
But motor oil is doing a lot more inside of your engine. It's a lot more complicated than you might think, and some of it is a little hard to see and understand. A quality motor oil is on the job 24/7 protecting your engine. One of the vital functions of motor oil is to protect the engine surfaces from acid, water, and sludge. This protection enables your engine to continue operating as designed and prevents rust and corrosion, two things you definitely don't want happening in your engine. Dispersants in the oil suspend combustion byproducts and other contaminants to minimize any deposits or sludge. The oil also carries any wear metals, dust, dirt, and other contaminants out of the critical areas of the engine to the oil pan or filter. When the oil is drained, these contaminants are then removed. It's one of the reasons why regular oil changes are so important to protecting your engine, getting rid of these trapped contaminants. Engines create power through combustion, and efficient combustion engines require a tight seal between pistons and the cylinder wall. Pistons are designed to be slightly smaller than the cylinder diameter, and therefore do not make a tight seal by themselves. The rings fit in the groove of the piston. They're spring-loaded against the cylinder wall to fill the gap, which changes with the temperature of the parts. Finally, a film of motor oil is held onto the cylinder wall by the cross-hatching or honing marks. This film allows the ring to move along the cylinder without wear and helps the engine create power by creating a good seal between piston rings and the cylinder wall. When there's not a good seal between the pistons and the cylinder, you lose power, efficiency, and fuel economy. Without a good seal between the cylinder and the piston, gases from combustion can blow by the piston, overheating oil and contaminating it with combustion byproducts like soot and acid.
Oil must flow freely through the engine. When the engine is turned off, most of the oil returns to the pan at the bottom of the engine. When you start your engine, the race is on to get the oil from the bottom to the top of the engine, to the camshaft, the lifters, the pistons, all of the parts that need the protection before the residual oil and additives are wiped away. A quality oil will win the race by flowing quickly at the startup and reaching parts and reducing drag when the engine turns over. If oil doesn't get there fast, there's a greater risk of metal-to-metal contact before the oil reaches moving parts.
Oils combat engine startup wear by having a multi-viscosity property. What does that mean? Well, all oils will thin out and flow better at higher temperatures. Viscosity is actually defined as resistance to flow, but an oil with a viscosity too low will not provide sufficient protection. A multi-vis or multi-grade oil, such as an SAE 5W30, will not thin out as much with the change in temperature as a monograde, like a 5W or a 30-weight oil would. This means that the multi-viscosity oil flows like a lighter oil, such as a 5W in cold starting conditions, and like the heavier oil, such as an SAE 30 at the hotter operating temperatures of your engine. Hot, cold, it doesn't matter. You're protected with the right multi-viscosity oil. Quality oils also contain additives that coat engine parts, so there's lubricant present on parts even when the engine is cold.
Now that you know more about what oil does, it's easy to understand that most oils do many complicated things that often conflict with each other. On one hand, you want oil to have a strong film protection, yet on the other hand, you also need the oil to be thin and flow easily for maximum power and efficiency.
Engines need oil to reduce heat, to prevent wear, to keep engine surfaces clean, to seal gaps between pistons and cylinders, and to flow to protect your engine startup.
So let's understand more about what happens to motor oil and how oil additives help your engine stay protected. The combustion of fuel and air inside engines creates pressure and power to move the engine, but it also creates contaminants like water, acid, carbon, and soot. Now, if that wasn't hard enough on an oil, we all drive in conditions that contain dust, dirt, and moisture that only add to the problem. And the high temperatures at which engines operate also contributes to the breakdown of that oil.
So let's take a look at some of the most common contaminants that can lead to oil breakdown. Deposits can form as either varnish and carbon or as sludge. Sludge is a sticky mix of fuel, oil, and water, often found on cooler parts of the engine, like the front cover, valve covers, or in the bottom of the oil pan. Varnish and carbon are harder deposits that start out shiny, usually brown in color, and build up to a dull, dark deposit. These can be tougher to remove.
Motor oil is made up of base oil and additives. Base oils make up around 80% of the motor oil. Base oils can be conventional petroleum, synthetics, or a mix of the two. Additives make up the remainder, around 20% of the oil. The base oil can degrade due to heat and combustion byproducts, where the additives are depleted or wear out as they are used in the engine. Over time, they must be replaced, and that is another reason why changing your oil is so important.
So let's take a look at some of the most important oil additives in greater detail.
Chemical additives are the active ingredients in motor oil. The additives protect the engine as well as protecting the base oil from degradation. Quality motor oil contains a variety of premium additives, including viscosity index improvers, anti-foam agents, dispersants, detergents, antioxidants, pour point depressants, anti-wear additives, and friction modifiers.
So let's talk about viscosity index improvers. Oil viscosity and flow can be affected by changes in temperature. In very high temperatures in the engine, oil can become less thick or viscous. This loss in viscosity can result in a loss of protection. Viscosity index improvers are additives that reduce the tendency of oil viscosity to change with temperature, providing extended cold and hot temperature protection.
That's right. It helps the oil to flow hot or cold, as we discussed with multi-viscosity engine oils. Anti-foam agents. As engine temperatures increase and moving parts churn up the oil, air bubbles can form, causing oil foaming and reducing the oil's ability to protect engine components. Anti-foam agents work to reduce entrained air or foam in the oil to maintain a strong film between moving parts. Air simply isn't a good lubricant.
Dispersants. Dispersants are special molecules in the oil that cling to dirt and soot and other contaminants in the oil. They keep them from combining and forming larger harmful deposits and keeping them dispersed in the oil. Dispersants are particularly important to prevent sludge formations at low temperatures.
Detergents. Detergents keep the engine clean by forming a protective coating that prevent contaminants from sticking to internal engine parts. Detergents also work to neutralize acids formed during the combustion process and are particularly effective at preventing high temperature carbon and varnish deposits.
So antioxidants. They protect the oil from thermal and chemical breakdown under harsh conditions present in modern engines.
Pour point depressants. At very cold temperatures, wax crystals can form in the oil. These crystals can grow to form large, harmful crystals. Pour point depressants work to prevent the formation of these large wax crystals, which can cause the oil to gel, preventing the oil flow at startup. The pour point is the lowest temperature at which an engine oil will flow. Typical pour points for an engine can be around -40.
Anti-wear additives. Under high load conditions, oil can get squeezed from between moving surfaces, leaving no protective oil film. Anti-wear additives provide a chemical layer of protection between metal surfaces to prevent metal-to-metal contact.
Friction modifiers are less durable than anti-wear additives, but provide a similar function by coating moving parts to reduce friction and improve fuel economy.
Now that you know more about oil additives, you can understand why oil formulation is so important to engine protection and understand why it's vital to change oil on a regular basis. Lately, there has been a lot of noise about oil change intervals. Should I change it 3,000, 5,000, or 7,000 miles, or even annually?
Well, you should always follow your manufacturer's recommendations and always change your oil filter when changing your oil. No exceptions. Don't they say severe drivers are the ones that need to change their oil more frequently?
Good point. So, are you a severe driver? You're probably thinking, no. I don't race on weekends, I'm not logging hundreds of highway miles a week. By the way, highway driving is not a severe condition. And I'm not hard on my car. Well, you might be surprised. Severe driving isn't what most people think it is. A recent survey found that 67% of all drivers are actually severe drivers.
Driving is considered severe service if one or more of the following conditions are met. Stop and go driving, short trips, driving in dust or sand, cold weather driving, extended high-speed driving, idling for extended periods, towing or rapid acceleration, heavy duty, and severe service.
These definitions don't include high performance on injection systems, like turbos and superchargers. These applications are definitely severe service, and Valvoline recommends choosing an oil designed for turbo or supercharged engines.
So you're thinking, okay, I'm a severe driver. Now what do I do? How often do I change the oil? The first place to start? Follow your owner's manual's recommendation for severe service. It's simply good insurance to keep your engine well maintained. Add the fact that regular oil changes can result in up to 2% fuel savings, and you get the idea. A little knowledge on your car care can save you a lot of money.
Now let's take a look at some key pieces of information on the motor oil label. The first involves selecting the appropriate SAE viscosity grade. There are two types of SAE classifications: single grade and multi-grade. All automakers recommend multi-grade motor oils today. Multi-grade oils such as 5W30 can be used across a broad range of temperatures. It allows for easy starting and pumping at low temperatures, yet it's viscous or thick enough at high temperatures to lubricate effectively. The higher the viscosity, the greater the protection. The lower the viscosity, the greater the power and fuel economy. Engine manufacturers design their engines and recommend viscosity grades to achieve the best balance between performance and protection.
By the way, did you know that the W in 5W30 stands for winter? An SAE 5W engine oil is tested to perform down below -30 degrees Celsius, -22 Fahrenheit.
Next, let's look at the API classification system. When new engines are developed, they require new types of oils. The engine manufacturers and the oil industry work together to develop new oil categories to meet the needs of these engines. The gasoline categories start with the letter S. Categories begin with SA and proceed through SB, SC, etc. as the performance requirements were increasing, all the way up to the most recent category of SN, beginning with the 2011 model year vehicles. The next category oils are already being developed for newer engines. As engine technology changes, the requirements on an oil changes. Even as API SN oils are the most recent performance category, technology is changing fast, and the Valvoline modern engine oil is designed for the latest gasoline engines where the fuel is directly injected into the cylinder.
The diesel engine categories start with the letter C. Like the gasoline categories, C categories start with CA as the lowest performance level. The highest performance diesel category is CK4, introduced in late 2016 for the 2017 model year engines. For the first time, diesel engine oils were introduced into the fuel efficient category FA4. FA4 oils have thinner film thicknesses at high temperatures and can offer more efficiency, but only on engines that are designed for their use. If surface finishes and tolerances are not appropriate, a thin FA4 oil may not offer sufficient protection for a diesel engine. The acceptance of FA4 oils is still not very broad, and caution should be taken to make sure your engine OEM allows the use of FA4 oils.
Generally, a higher performance oil, for example an API SN, can be used whenever a lower performance oil, for example API SL or earlier, is called for. The intention is to be backward compatible. This is part of the reason that the FA4 category was kept separate from either the S or C categories.
In addition to meeting the API S category for engine protection, gasoline engine oil may also provide fuel economy benefits in carrying the energy conserving designation. Oils meeting the latest API category in energy conservation are the primary recommendation for North American and Asian engine manufacturers.
These oils carry, in addition to the API service symbol, the API certification mark, or Starburst, designating that they meet the requirements of ILSAC, the International Lubrication Standardization and Approval Committee. ILSAC is a joint effort between North American and Japanese engine manufacturers.
All right, you've consulted your owner's manual. You know which viscosity to choose, but which brand do you choose? What kind of oil do you choose? Conventional oil? Synthetic oil? What if you drive a car or a truck with a lot of miles on it, or an SUV or a truck you're going to use for towing?
Well, let's start with conventional motor oil, like this one from Valvoline. Quality conventional oil provides good, solid year-round protection.
Or if you do have any hauling or towing you want to do, consider the added protection of a synthetic blend product, which mixes full synthetic with the conventional. Now, I don't know about you, but I remember my first ride. It had tons of miles on it. For anyone driving vehicles with over 75,000 miles, higher mileage motor oil is a great option. Engines age kind of like people. Over time, seals harden and become more brittle. Clearances, the gaps and spaces between the metal parts, become larger, and vital engine components begin to wear out. These conditions result in increased wear and tear on the engine, decreased performance, and increases in oil consumption, added deposit formation, and often the telltale leak on the driveway.
Now, quality high mileage motor oils are designed to provide extra benefits compared to regular oils. They contain special conditioners to help restore engine seals, to make them more elastic and prevents leaks within the engine. They can have extra detergents to prevent deposit formation, and some have additional anti-wear additive to prevent future wear.
Well, what about the synthetic motor oil?
If you're looking for the best protection for your vehicle, synthetic engine oil should be your choice. These products are made using higher quality base oils, which provide two main advantages: better high temperature protection and better low temperature protection.
But isn't full synthetic just for newer or high performance engines?
That's a great question. But it's important to note that all engines, from minivans to hot rods, have parts that reach in excess of 400 degrees. Don't be fooled by that dashboard temperature gauge, which is measuring water temperature. We mentioned earlier that oil comes in contact with the hottest parts of the engine. At 400 degrees, conventional oil can break down faster than a synthetic base oil, causing long-term issues from deposits, like we discussed earlier. Full synthetic oils don't begin breaking down until even higher temperatures, so they tend to remain stable and allow the additives to do their job. Speaking of additives, even though the additives used in synthetic lubricants are the same types as the ones used in conventional products, quality synthetics may use them at higher levels. This provides not only the benefits of a superior base oil, but also the benefits of a superior additive system. The result? Extra confidence and protection.
Okay, I have one for you. My buddy races on the weekends. You probably recommend a full synthetic for his race car, am I right?
Well, that's another great question. But a race engine has unique needs compared to a passenger car. Some racers still use passenger car motor oil for racing, but most race engine builders will tell you that you just shouldn't do that with modern passenger car oils. The main reason is that passenger car oils contain lower levels of the anti-wear additives zinc and phosphorus because of modern emission systems. Racing engines need a high level of anti-wear, so even a full synthetic passenger car oil is probably not as good for racing as an oil specifically formulated for racing. Racing oils are also formulated with horsepower and high heat in mind. Now, choose the right motor oil for your vehicle and your driving habits. Read your owner's manual and go with a brand you trust.
All right, now we'd like to bust some myths. Here's the first one. When a motor oil turns black, it's no good.
Myth. So motor oils are designed to disperse soot and other combustion byproducts. They can turn black very early in the drain interval and long before the oil's used up. So if it's thick and black, it's used up.
All right, here's another one. The lowest quality synthetic oil will outperform the highest quality conventional oil.
Also a myth. Performance is a function of base oil quality and performance chemistry. A conventional oil with a very strong additive package can outperform a full synthetic with a weak additive system.
Well, all right. Myth or fact? All motor oil is motor oil. High mileage motor oils are no different than any other oil.
Myth again. Some high mileage motor oils may be little more than a conventional oil with a little bit of seal swell agent. But quality high mileage oils are designed with extra additive to address the changing needs of higher mileage engines. Quality high mileage oils have seal conditioners, extra detergents, and extra anti-wear additives, and use higher quality base oils. They're formulated to reduce oil burn-off, minimize leaks, provide greater wear protection, and keep your engine cleaner.
Wow, that's pretty smart. Okay, here's another one. Thicker oils, or heavier viscosities, provide better protection than those thinner oils.
Well, it's true that using a thinner oil than what the manufacturer calls for can result in reduced engine protection. Using a heavier oil than what the engine was designed for can have its own problems. A thicker oil will require the engine to work harder to get the same horsepower. This means greater fuel consumption, more heat generated, and greater strain on the engine and the oil. The engine designed for thinner oils may generate excess heat in the oil by pushing the thicker oil through tight clearances. Your best bet is to use the viscosity grade recommended by the engine manufacturer. If you have to go to another viscosity grade, it's safe to go higher on the high number and lower on the low W number. It would typically be safe to move from a recommended 5W20 to a 0W30, but you would not want to do the opposite.
Okay, well, here's a riddle. You cannot switch from a conventional to a synthetic or vice versa.
So, modern synthetic base oils are completely compatible with conventional or petroleum-based oils. In fact, in most applications, it's safe to switch from conventional oils to synthetic to get better protection. It doesn't lock you into using synthetics forever.
Well, on behalf of Valvoline, I'd like to thank you all for coming with us today and learning a little bit about motor oil.
Good luck and have fun.